Hi, in this tutorial I'm going to talk about electrocardiography. So we'll be looking at the first principles of an electrocardiograph, more commonly known as an ECG or an EKG in the United States. There's a fair bit of information in this tutorial, but I'll try and make it as simple as possible. So first of all, we're going to look at where you attach the leads of an ECG machine to a patient. First of all, there are 4 leads which are attached to the limbs of a patient. These are abbreviated LA for left arm, RA for right arm, LL for left leg, and RL for right leg. There are also 6 leads which we attach to the chest of the patient. These are called the chest leads. Now this is a point of confusion for many people when first learning the ECG. There are these 10 leads which we have attached to the patient. But this is not what we mean when we talk about ECG leads. An ECG lead is a mathematically determined recording which is made up from a combination of these physical leads that are attached to the patient. So from here on in, when I talk about an ECG lead, I am going to be talking about these mathematically determined recordings. You don't need to know how these leads are calculated. Just know they are not the same thing as the leads attached to the patient. So in a 12-lead ECG, which is the standard ECG, there are 12 of these leads, and each lead shows the heart from a different view. So if I draw up a heart like this, and we're looking at it from the anterior aspect, we can think of these leads as little eyes that each see the heart from a different angle. So there are 6 of these eyes that look at the heart in a coronal plane. And they look at the heart in the directions I've shown here. And each of these leads has a name. This is lead 1, this is lead 2, this is lead 3, and the others are called AVL, AVR, and AVF. This stands for augmented vector left, right, and foot. The chest leads look at the heart in a transverse plane. So again, these work like little eyes that each look at the heart from a different angle. These are labelled much more simply. They're called V1, V2, V3, V4, V5, and V6. And that's the front and the back of the torso. Now let's have a think about the limb leads again. If I draw up a diagram of the lead directions without the heart, we get an image that looks like this. If we extend these lines out in the opposite direction to which they point, we will see that we have every direction covered in 30-degree increments. Now would be a good time to talk about what I mean by looking at the heart. The ECG can't see the heart in the way an X-ray can. It sees it electrically. That is to say, it sees whether there is electrical depolarization or repolarization occurring in the direction of each lead. If you don't know what I mean by depolarization and repolarization, I'm talking about the flow of cardiac action potentials through the heart. You can check out the Action Potential series at www.handwrittentutorials.com for more information. So let me explain this a little further. I'm going to draw up a heart here, and we're going to look at recordings that are taken from lead 2, lead 3, and AVR. And we're going to look at the depolarization which is occurring in this direction. So any depolarization that occurs in the direction of a lead causes a wave on the graph which is positive in nature, that is, an upward deflection. So because lead 2 is roughly the same direction as the depolarization, the wave on the graph will look like this. Because lead 3 is perpendicular to the direction of depolarization, there will be no change in the graph. And finally, because AVR is in the direction opposite to the direction of depolarization, there is an inverted wave or a downward deflection. And that's an overview of the first principles of an ECG. In the next tutorial, we'll be looking at the normal pattern of an ECG during the cardiac cycle. For more free tutorials and the PDF for this tutorial, visit www.handwrittentutorials.com.